where we use like type def and make pointers to point functions. That,
Yeah.
and then the using new and delete, the allocating dynamic memory. That one, Fibonacci and hex addition. So to be fair, like the rest, I'm not that worried, like, but we can go through like the ones that we are actually like weak in. So I don't know much about riddles, to be fair. And also like regarding Fibonacci, and like when he was doing Fibonacci, he actually said like, okay, there's like, okay, these are the binary numbers. Like, how do you write binary in 0 and like 1, right? And then as far as like I know, I think like like the first half is like 0 to 3, and the lower half is like negative. I'm not actually like good with that. I don't know how he's gonna
I know how
ask
to
that.
do it. You want me to teach you?
Yeah, like, but if everyone like, I would prioritize others also, like see if they have anything to
Honestly,
anything they want to
it's like
go
a
over.
queue-based system, so whatever is getting requested first. So if you have a request right now, since no one else has anything, I know Chris. Well, do you go by Christopher or Chris?
Man, don't worry.
Alright, so I know Chris wanted to do Tower of Hanoi. So it's
Mm-hmm.
up to him really if he wants to start with Tower of Hanoi, or do you guys want to do whatever Phoenix wanted to go over real quick? Me personally, I kind of want to take a small look at Stable Marriage as well as the final problem that we had, like that I sent to Chris.
Mm-hmm.
So if you
Well,
want,
regarding stable marriage, yeah, I know pretty well about stable marriage. So yeah, we
so
can help each
let's set up a queue,
other.
okay? For today, here I'll put it up on my screen. For today, menu. So what do we want to do first? Tower of Hanoi, like the binary thing. Anyone? Chris?
I'm good. If you want me to start, I'm good.
Okay, so Tower of Hanoi first, or Phoenix? Do you want to go over the binary stuff? Like, who wants to go first?
Let's go over Tower of Hanoi first, because I think that's more complicated. I think like we can catch up on binary pretty fast.
So Tower of Hanoi rerun, small lesson on binary, and stable marriage. Yes or no?
Yeah, we
Yeah.
should go over stable marriage.
Stable
Definitely, he's gonna ask. But
marriage
he was not in the midterm.
rerun, and if time permits us, we can take a
Are you
look at
sure?
the.
Are you sure he's gonna go over stable marriage? Because I know that those problems were like in the midterm, and I think he's gonna put a new labs. No.
You think
If I
stable? You think stable
It's
marriage was in the midterm?
cumulative, you know. It's
Mm,
supposed to be in the midterm, I mean, like, course wise, the progress wise is supposed to be in the midterm, but considering the fact that he actually like told us to do this and it was not in the midterm, so I'm not sure. Like, for me personally, I got stable marriage. So if you guys want to like like leave it, it's fine with me.
For now, we'll keep it at a maybe. Other than that, like, oh yeah, we do have a sample of a previous finals problem. It's actually a previous final riddle. So if time permits us, we can get on that as well.
Yeah.
So does that seem fair with everybody, or do you guys want to shift priorities from one or the other?
Okay, I think we should do Tower of Hanoi.
Uh huh.
Then we need to go over binary
Okay.
Fibonacci code, the
Okay.
Fibonacci function.
Slash bone. I don't know if I'm spelling this right.
Okay, and
I think it's an I,
we
right?
need to go over. You guys already went over the red class, right?
Yeah.
Okay, I'm gonna do it by myself.
No, if you want, we could also do that. I mean, like we could just like go over it again just to like refresh. It's all, at the end of the day, it's up to you guys. Cause yesterday we like if there's people from yesterday who still have questions, we could always go over that.
Yeah, for me, I'm having problems with the operators thing.
Okay, so do you want to put this above stable marriage or below?
I think above.
Above. All right,
We
just
should
like
put the new stuff first, and then like what we learn because we already studied for that, right? For the midterm, so we
yeah.
have like a little bit of knowledge of that.
So
So I think we're gonna do
rad
that first.
class, Tower of Hanoi rerun. This was actually already done in session one, but today, since you have a very good knowledge of it, we can always do a quick rerun on it. Small lesson on binary and Fibonacci. Quick recap on rad class operators. Stable marriage rerun. I'll keep it at a maybe for now. And final riddle from the previous finals.
Mhm.
So anything else from people in the chat? We have the IRA in here. That's an insane name. And then wait, is it ERA or IRA? Like the agency IRA? And then Steven and Blank. If anyone has any other suggestions that we could add to the list, if not, we'll get started.
Then dynamic array maybe.
Dynamic array. Okay.
Mhm. What's a
Dynam.
dynamic array? Oh, the dynamic allocation?
Yeah, the
Oh
new array. Yeah.
We could always shift the order of priority as well. So we could always keep this at first, and once we're done with this, if we want to go on to another one, we can cut that off. It's kind of like a list. So whichever works for whoever. So, Chris, you wanna start sharing your screen, or do you want to like send the code and I can share it and you can explain step by step?
Oh, sure, sure.
Okay. Uh, okay. Whenever you're ready.
That's me.
Let me take a look. Since it is going to be on the live stream as well, I am gonna stream your stream.
Yeah.
Pop out.
So let me erase this. You guys ready?
Of course, yeah.
Okay. So, first for Towers of Hanoi, I recommend to initialize to start with like the vectors, right? So we wanna do vector and T3, right?
Yeah. If you don't mind me asking, what is vector?
Vector is basically a dynamic array. Eventually, it shrinks and it can get longer in compile time.
So
So
it's adjustable essentially.
yeah, it's adjustable.
Perfect.
For example, when you put an array and you put like size n, it doesn't work. It will give you an error, right?
Yeah.
But for Actor, you cannot have a size. You can literally add it while the program is running, right?
Uh huh.
Okay, so then we wanna ask the question, right? So enter number of rings. So this is gonna be step one, okay? Step one. Step one. Then we need an n. You need to need init n and cin n. Okay, this is step one. There's 4 lines of code.
Uh huh.
I recommend you to memorize each step or try to understand it. Okay. So first, what we're doing is creating a vector of integers that has basically 3 vectors. So we can imagine this as something
I'm
as
assuming that's 3 towers, correct?
yeah, 3 towers. So 1, 2, 3, right?
Uh huh.
And here on top of these towers, we're gonna create a vector that's going like like vertical, right? So
Uh
the
huh.
numbers going vertical. So this 3 is basically 3 towers. 1, 2, and 3.
Got you.
Okay. Oh, okay. So then we're gonna do step two. Step two. We're gonna initialize everything that we need, right? So we want to move something from something to something, okay? From a tower to a tower. So we need to initialize an end. It's gonna be from, right?
Uh-huh.
So we're gonna move from tower 0 to tower 0, right? Because it is in array and vectors, we always start from 0, 0, 1, and 2, right?
Yeah, 0, 1, 2.
Yeah. So we're gonna move from 0 to and 2. So this one is a little bit tricky, okay? Because this one is called a ternary variable, okay?
Now, what is a ternary variable?
Ternary variable. So it's basically it's an it's like saying if else, right? So let's say this: if n is an even number, right? So if it has a mod of 2 and equals 0, it means it's even, right?
Yeah,
So if it's this, we're gonna make it 2 is gonna be equals to 2, basically. If this is true,
that
it's
is
gonna be
equals to
2.
2.
Okay. Else, this we're gonna represent it as else, right? Else, if it's not even, if it's an odd number, right? We're gonna make it to 1. So this makes a ternary variable, okay? So it's parentheses, uh, question mark, and 2 numbers, right? Dot dot. The other option. First option, second option, right?
So,
So if this is true, it's equals to this one, the first element. If 2 is the opposite of this, so if it's an odd number, it will equal the second option. Okay?
I see, yeah.
So you're putting
It's
two
the
values.
same with if else statement, right?
Yeah, right. Exactly the same, right? So you're giving two variables or two answers to 2. It depends on if it's even or odd. Okay? So I recommend studying ternary variables because that part is a little bit tricky. Okay? But it's almost same as if and else.
Okay. Anyone in chat has a question so far? Okay, I mean, I guess no one.
Okay. So we need a this part is gonna be important for later, okay? The close end closest. This part you're gonna understand it why we need it for later, right? So I'm gonna explain that when we are gonna use this, okay? But it's gonna have the same as this one. It's gonna have the same as this one. So if it's even, we choose 2. If it's odd, we choose 1. And var equals and mod 2 equals 0. This one is gonna be the opposite, right?
1, 2.
Is
So,
is an easier way to do this, but I'm doing it this way because it's easier to understand, right?
it's giving like a visual effect to it. I see it. So,
Okay, so yeah,
I
so
have a
if
question here, if you don't mind me asking.
yeah, sure.
So, I noticed that you had you had three different integers, right? Like, obviously, from is equals to 0, right? So,
Uh
because
huh.
you're starting from tower 0, I'm assuming.
Uh huh.
And int 2 is to determine whether or not it goes to tower 2 or 1.
Yeah. No. It's basically it checks if it's going right or it's going left. For example, if you have 3 towers, right? And
Yeah,
you're in this one, it decides if you're going to this tower or to this tower, right?
I
But if
see.
you're this one, it decides if it's going to the right, and if it moves to the right, it goes to this one. It moves to the left, it goes to this one. So let's say if you jump to the right here, it would jump back to the front and go to this one.
I see. Okay.
Okay.
Then, how does the closest and farthest come into play?
So that's to see. Um, let me get to the part and I'll explain. Okay.
Okay, yeah, yeah. Go on, my
For
bad.
that's like saying that's for saying well which one is the closest to which one? I'll explain it later. Okay.
Yeah, it's alright.
I'll
Yeah.
explain it later. Okay, so this is step 2. So right now we have step 1 and step 2. So I recommend memorizing the steps or taking a picture and just like reading and go over the steps. So right now we're gonna go step 3.
Got you.
Okay. So now we wanna initialize the vectors. So how do you initialize a vector? With a for loop, right? As the same as an array. So we put int I is equals to n plus 1. Why n plus 1? Because we want like a bigger number to know where the towers are, right? For
Uh huh.
example, let me explain it better.
Is it because you're moving from tower to tower?
No, it's
Yes.
a sentinel value to have
Yeah, it is a
the
sentinel
biggest
value, yeah.
sticks in the bottom.
I see. Okay.
It's from avoiding us to check if a tower is empty, right?
Mm-hmm.
So if you have a value, you just skip the step of checking if it's empty or not. So because you have a value there. But you're not gonna use that value. It's just to see if you have a tower there.
So it's just a placeholder essentially.
Yeah, it's a placeholder.
I see.
Exactly. Okay. So then I'm gonna do I is greater or equal to 1. Because let's say if you have like 5 value, right? You have 5, 4, 3, 2, 1. You don't want to serially make it to 1. So you want I to be
In
greater
what?
or equal to 1. And then minus minus I. Okay, so then we're gonna be first tower. So tower 0 is gonna be a pushback. So don't make it equal to I. It's a pushback because it's a vector, okay? Pushback, parentheses, I. So basically, this tower, let's say if we put n equals 4, right? So this tower is gonna be, so n plus 1 equals 5, right? But because we have minus minus before the I, this is I equals is gonna equals 4, so not 5. You understand what I'm saying? Or you got lost?
No, I know it. Yeah.
Yeah,
You know
I
what I'm
have
saying?
I have a little understanding. Yeah.
Yeah, so because let's say if n equals 4, is n plus 1 is 5. But because we have minus minus in I, the before I is gonna be 4. Okay? And then we're gonna use t1 is gonna equal to, oh no, you see, I almost made a mistake. Pushback n plus 1. So here we use this, the value the n plus 1, the sentinel, and t2 dot pushback. Anyone knows what is gonna be in between the parentheses?
Um. And minus one.
N+1.
N plus 1, because we want to put sentinels on them, on the towers, okay? So this is the sentinel. So here's gonna be n plus 1 as well. So it's just a placeholder, basically. Okay. So this is our vectors. So this is our 3 towers. Okay. So this initializes our 3 towers. Now we're gonna do step 4. So now here where the code begins. Here's the while loop that's gonna make everything move. Okay. So into the while tower 1 we want tower 1 because we want all the answer in the middle, right? We want how it's gonna be 3 towers. We want all the answers to be in the middle. Well, tower 1 dot size is less than n plus 1. So this means that you're gonna go to tower 1, the middle tower, right? You're gonna see how many elements it has. And let's say you choose 4 elements, right? But because it has the placeholder, you want to make it less. You don't want to make it less or equal to, because you don't want n plus 1 to appear in your answer. Okay?
Yeah, so that means that it always has to be less than like the +1, right?
Yeah, so the size of the middle one is gonna be equal to the size that you want. It's gonna have all the rings, but except the placeholder that we put right here. That's why it's less. That's why it's not less equal to.
I see.
Okay?
Uh-huh.
Okay. So here we're gonna do C out, and we're gonna write or how it's gonna or output is gonna be, okay? So we have C out. Oh, let's do a counter just to make it better. So move and counter equals 0.
Wait, I have a question here. So why did you just add the counter?
Oh, just to make it look better. It's just to make it look better and see how many moves we did.
Oh, so it'll
To count
output
the
like
moves.
exactly how many moves occurred during
Yeah.
like the rearrangement of the pieces.
Let me fix this. Move. So it's a move counter, okay?
Counter. Okay.
Okay, so we're gonna put move number move counter. So every time we're gonna move, we're gonna go back to the while, and we're gonna add this. Let's add this. So move plus plus move counter. So move number move counter. Okay, and we're gonna do like this, and we're gonna see um transfer. How we can add? Let's add transfer ring. So anybody knows what is a ring?
That's the N, right?
No, it's gonna be called the candidate. Oh, we forgot the candidate. Wait, and candidate equals to 1, right?
Oh,
So a ring is always gonna be the candidate. So we want transfer ring 1, right? Candidate from tower. Oh my God. Okay, so this equation that I'm gonna do right here. Wait, let me put it right here. Is in order to get one number or what tower to tower. So this make sure to know this thing right here. So char from plus character A. So because from right now is 0, right? So 0 plus A is gonna be A, right? But let's say from is 1. So 1 plus A is gonna be B, right? From A to tower char 2 plus a and 9. Any questions with this part?
Yeah, actually, I have a couple.
Okay.
Okay, so let's start from step 2, right?
Okay, step 2, right here.
Can you explain each of the initializations you did for integer, like for each of the
Okay.
integer values?
Okay. So from is the tower that we're gonna choose our candidate from.
Oh, okay. Uh huh.
So from is where the ring that we're gonna move. From this tower, we're gonna grab this ring and move it to this tower, right? So from we're gonna let's say let me right here.
You can always hear. I'll show you the Google drawing, and you can like just type it there. Okay.
Okay.
I'll send you the link right now.
Are you send it to me or?
Yeah, to you. Whatever you want to type, you can type there. Here, I'll make it small.
Can I draw on this thing?
Yeah, of course. Here. Eyes to like.
How do I draw? How do I draw? Like the shapes. Okay, let's say we have this tower, right?
Uh huh.
And we have this tower.
Uh huh.
It's not drawing.
No, it's because it goes away. Yeah.
We have this tower. And we have this tower. Okay?
Yeah.
So, and from this, we're gonna have the rings. There's not a pen here where I can draw or paint.
Wait, what are you trying to draw? I'll draw it for you.
Let me use paint.
Actually, that would be better. Yeah.
Is there a
Paint.net.
paint here?
Benim böyle bak ki hoysun.
Gonna try. Wait, Microsoft.
Anti bu şey hala suda bir koydular.
Harvey, if possible, can you mute? Thanks, man. But if you have any questions, you can always unmute and ask.
Okay, found it. Okay. Okay, but okay, so we have tower here. Can you guys see this?
Yeah.
Yeah.
We have 3 towers. So let's say we put n4, right? So it's gonna be like 4, 3, 2, 1. This one is gonna have n plus 1, so it's gonna be 5, 5. Okay. So this is n plus 1 equals n plus 1.
And that's temporary, right? It's not gonna be
Yeah,
remaining.
temporary. And this one is equals to I. Okay.
Uh-huh.
Okay. So basically, what we do from is gonna be this from. So let's say this is index 0, 2, and 3. From is this right now. Temporary also from. From is 0. Okay.
Mm-hmm.
2. You saw it was a ternary variable. So 2, it can be this or this, right?
The ternary variable is changeable.
So that is n mod mod 2 equals 0 question mark 2 dot 1. Okay.
Yeah.
That means let's say if n equals 4, right? 4 mod 2 is 0, so it's 2. So it will be this one. So you need to move. You need to grab from this tower and move to this tower.
The letter n, or I mean the number n, or ring number 2 or 1.
No. Basically, 2 means this tower. So this means you're moving from to this one.
Okay.
Let's say if this is all right. If this is 5,
Yeah.
5 mod 2 equals 0. It will be 1, right?
Yeah. So it's gonna.
2 equals. Oh my god, bro! I confused myself. What the hell?
I would type shit.
So shit. Okay, so
Okay, it'd be like that.
2 equals 1.
Well, what are you trying to do right
Bro,
now?
I
The
fucking
logic.
leave for 5 seconds and I just see a whole bunch of circles and lines, bro. Hold up, hold up,
No,
hold
like
up.
I want to know the logic what you're trying to do, Christopher.
I'm trying to show them what is 2. Why 2 is the ternary variable.
You
Oh,
wanna the first iteration to move to choose the two tower.
Yeah, right? Because he's asking why is 2 equals to the ternary variable.
Like n mod 2 equals 0.
Yeah, basically.
Is he asking like why 2 is equal to like 1 or 2?
Yes.
Oh,
He's asking this. He's
yes.
asking this one. He's asking why we
Which one?
initialize 2 to this.
Oh, okay. Go back to the towers, please. So, if we say like the leftmost tower, tower 0, we're gonna move from like tower 0, right? So, the logic is if the number of disks n is odd, we're gonna move like clockwise, which means from 0 to 1. So let's say like the left most tower is tower 0, the middle one is tower 1, and the rightmost is tower 3. So if the n is like odd, we're gonna move like to the right. So the two tower from tower is 0, and the two tower will be tower 1. If n mod 2 is equal to 1, which means n mod 2 is equal to 0, which means the n is even, we're gonna move like counterclockwise to the left, and that's why 2 tower will be equal to 2.
Okay. So basically, it's saying that if this is even, we move it to the left, right?
Mm-hmm. The
So
counterclockwise.
if this is even, right? Because 4 is even, we move it right here to the left, so it goes to this one. If this is odd, it moves to the right, so it's this one. You get it?
Yeah. So, say I put like, if I were to input like a number of rings, and I put it at like, say 6, what tower would it go to first if it ran in through the 2 statement?
So 6 mod 2 equals 0.
Yeah.
So we'll go, it's an even, so we'll move left, so we'll move to this tower.
Okay. But so if it was even, then it will move to the right tower.
No, if it's even, it moves to the left. If it's odd, it
Uneven.
moves to the right.
Right. Okay. Okay, I get it now. Ah, that's cool. What about?
Excuse me.
Yes?
Yeah, can you go back to that over there where you were? Okay, so yeah, exactly. Yeah, so when you put n mod 2 equals 0, okay, I get that. Like it means that it's even, but can you just explain like I'm to be honest, I haven't been on this like for a little while. So that question mark and then 2
So
colon
this,
1. Uh-huh.
so
Yeah.
you basically want to know this thing, right?
Yeah. Like just
So
like
that's a,
can you translate it into words basically?
okay, so basically, 2, it can have 2 answers, 2 or 1, right?
Okay.
So it basically says, uh, n mod 2 equals 0. If this is
Mm-hmm.
true, it's 2.
Yeah, is
Else,
divisible by 2.
else else if this is false, is 1.
So that question mark means what? If
So
else?
basically,
If
if n is even, the 2 equals 2. If this is not true, so 2, if n is odd, 2 equals 1.
It's
Okay.
another way of writing if else statement.
Yeah.
Yes.
So instead of doing
Oh,
like 3 different lines to like run the program, you can just do a question mark, and it'll like the system will understand it as like a if else kind of thing.
okay.
I
So
think.
if it's saying like n mod, so if it's divisible by 2, I mean
If
n
it's
mod
even,
2 equals n mod 2 equals 0 means that it's even because it's divisible by 2, right? And then the
yes.
question mark basically says if else it is 2, and then I don't get
Else.
that colon one. Oh,
Colon is
2
else.
else 1.
It
2
can be
else 1.
either. Okay, so in words, like you said, the question
Yeah, it'll be
mark,
two
it's a
else one. Yeah.
yeah. So it's like 2 else 1. So if it is even, then it's gonna be 2. Else, it's gonna be 1.
Ah, okay, okay. So then it would go to 2 is the tower all the way to the right.
Uh huh.
Oh, okay, and
Yeah.
then else 1, the one right next to
Yeah.
it.
Yeah.
All
Yes.
right,
So
all right. Thank you guys.
okay. So I see. Chris, if you could go back to the drawing. So in this case, you put it as 023, but it's actually like 012, right? Like
Yeah,
it's
yeah.
go.
Oh yeah, 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 yeah,
That
yeah, yeah.
that kind
Yeah,
of
yeah. I
doesn't.
was like, yo, where did 3 come from? No, but I see what you mean now. So like, if it is even, then it's going to the left,
Yeah,
Phoenix said, counterclockwise.
yeah.
And
Okay.
if it's odd, then it's going clockwise. So in this
Yeah,
case, like 1 is going clockwise, like the ring number 1. It's
yeah,
going to the like tower right to the right, and then ring number 2 is going all the way around to the left. It is doing like an anti-clockwise turn. Then 3 is going to
Yes.
that one. 4 is that yada yada, and it goes on to the next tower based on the code.
Okay.
Mhm.
All right. Thank you.
Now, thank you
Okay.
for the question, and thanks for the explanation, Chris.
Okay. Okay. So closest. This is. So this is for the closest tower that you have near, where you're gonna place the ring. The closest you the if you're in the middle, the closest tower to you is this one, right? It's hard to explain. This part I'm gonna explain at the end, as I say before. Okay.
Okay.
Okay. So with this part, anyone has questions?
Not really. That's just like showing it's a counter, right?
Yeah, it's only counter and like choosing the ring from tower A to tower like the other tower. Let's say from the tower you are in to the other tower that you're gonna move.
Yeah, I see.
Okay.
Uh huh.
So this is step 5. I'm doing by steps just so you can. It will be easier for you guys to like if you wanna
Memorize.
just memorize your stuff or something.
Thank you.
Step 5. Okay. So now we're gonna move the rings. So this is the stuff we move the rings. This one is easy. It looks hard, but it's easy. Okay. So we want to move the ring to the 2 tower. Okay. To the 2 tower because we will push back. Okay. We're moving something. We're moving the ring to the 2 tower. But what ring are we moving, right? So we're moving the ring from the from tower dot back dot back. Why didn't I use pop back or push back here? Because we use pop back, that means we're erasing the last element. If we're only gonna grab the element, we only use back. We're like just checking on it, okay? We're not doing nothing to it, we're just checking on it. So we grab that element, it's like copy and paste. We're copying.
So
Yes.
so basically you're saying like dot back, so you're getting the last well, yeah, the last element you had from the, hold on, and adding it to the 2, to the
Yes,
2 tower
basically.
that we're currently going to.
Yeah, we're getting the last ring. We're getting the smallest ring in the from tower. So
Mm,
the ring that is on top of everything, right?
right, right.
And we're getting that ring and we're adding it to the 2 tower.
Okay.
But this thing doesn't do anything to the from tower. So the from still has that element. We don't want that because that's gonna cause errors because we're
Right.
gonna have two elements of the same, right?
Yeah.
So now we need to erase that element. Anyone knows what function we need to use?
Call back.
Yes, pop back from dot pop back. Okay, so this is
So
step 5.
that basically means like it's no longer on the last tower, right?
Yes, that means we got the element from tower and we erased it completely.
Okay. Well, completely from that tower.
Yes, no, and now that element is in the 2 tower. We
Yeah.
copy and
Yeah.
pasted it and we erased it from the
Okay.
from tower.
Oh, okay. So for each move you make, you erase the previous like storage value from the previous. Well, technically these
yes.
towers are like kind of erased. So you move one value to the next array, and then you erase the previous value in that array.
Yeah.
Oh, that's okay. That's cool. That's cool.
Okay.
Yeah, we need to like copy the value first because I think like the back is just it copies, it returns the value, but it doesn't remove the value. But pop back it removes the value but does not return the value.
Okay, so I
So
kind
if
of
we
see
do
it.
like if we do pop back first, there will be no value to like copy.
Like transfer
There
over.
would be yeah.
Yeah, the value will
It's
be the other smaller one, which will have an error. So
in this case is like push back, kind of like copying. Back is like pasting, and pop back is like cutting, right?
No, pushback is
um
is adding to the last adding is like adding another element to, and you're adding an extra element and adding the value.
Okay,
Kind of like
so
that.
you're
So
pasting the
pushback,
value with push
yeah,
back.
pushback is putting a new value, like in an array, right? You have like many of these things, right?
Yeah.
So pushback, it adds a new one, right?
Uh huh.
Back is just like selecting it, copying, and we paste it to another one, right? Wait, my bad. Like it didn't cut it. It just like the value still there. It's still there, right?
Yeah, that's what
But let's
back
say,
does.
yeah. But let's say we no. This back is basically just
Copy.
getting this,
Back is like the
getting
copy.
this, copy, and then goes to this one, adds it to this one, right? That's basically what it did. But
Okay,
you see how the new is still there?
that pop back erases that.
Yeah.
Basically,
Okay.
go back, goes to the front tower, gets this thing, and erase it. But we still have the new one over here.
Okay.
Like back basically kind of doesn't do anything unless you combine it with something else.
Yeah, it's just a copy. When you press copy on your computer, right? Let's say, look, I copy. It doesn't do anything. You just copy it.
Yeah.
Right? But if I come here and paste it, it does something.
Yeah.
That's what the pushback does for it.
Yeah.
Combined with the dot back.
Oh, okay. I see it. I see the vision.
the tower from dot back is just returning the value at the back of the from tower.
Yes. So this is like ring from this one, push it back to this one.
Is like you push back the element at the back of the well whatever, like array or vector whatever, into the the two tower, and then the pop back takes it out. I mean, you know that one, I think, already.
Okay. So now we're step 6. So we just erased or from pop back, right? So we need another from because we already used that. Use it for that tower. So now we need to use another tower to grab the ring and use it, right? So we need another from.
So
So
does
for this
this?
we're gonna use.
So sorry for interrupting. Does this occur 3 times in total?
What do you mean?
Like the pushback and back, we have to do this 3 separate times for 3 different towers.
No. This because it has the while loop. You see the while loop?
Also, it does. It like keeps on doing it until it's complete. Oh, okay.
It's gonna blah blah blah. Wow, blah blah blah. Push back, boom, 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 and it grabs the other tower. Boom, boom, boom. Okay.
Yeah.
Okay. So we're already doing step 6. So we will need another from tower. So we're gonna do an if statement, okay? If tower, this part is a little bit tricky, okay? But it's easy. Just everything is easy. It's just hard to understand, but while you get it, it's easy. Okay?
Yes.
Yep.
If tower, okay? 2 plus 1 mod 3, right?
Yeah.
Okay, if that tower is less than tower 2, 2 plus 2 mod 3. Okay, what does this mean? This
No.
means oh wait. Where we did something wrong here. We're gonna use back. Back. And where's the other one? Dot back.
So, I mean, I guess it kind of says like if the element in the last element of the two tower plus 1 divided by 3.
There's
Oh
not
no,
divided by
mod 3 is less than the element of the 2 tower plus 2 mod 3. But
So
what do
that
you?
basically means from the 2 tower we move plus 1, right?
Uh
So let's
huh.
see, the 2 tower is 2, right? So you're in tower 2, which will be the last one, right? It will be the last tower.
Yep.
The 2 tower plus 1 is 3, right? 2 plus 1 is 3.
Yep.
Yes.
Mod 3 is 0, right?
Yes.
Yep.
So you're grabbing the you're grabbing tower 0 and you're using the last element of that tower, the last ring of that tower, of tower 0.
Oh, that's just kind of fire. Okay.
Because what this does, you're not is like you're choosing other towers that is not the 2 tower. So you're
Mhm.
using 2 towers except the 2 tower. You get it? Because you're using plus 1 and plus 2.
Oh, so
You're
you're
not using the 2
avoiding it.
tower alone. You're
You're...
avoiding it.
Oh, okay, got you.
Yeah, mod
So
3 basically just like go around the towers, right?
yes, basically.
Mm.
So it'll be like if the 2 tower, right? If the 2 tower is 2, you're getting this 3 mod 3 is 0. It goes to the first tower, right?
Oh, so it like helps skip certain towers that would interfere with the
Yes,
moving the rings.
it skips the 2 tower. Okay,
Oh,
because
okay.
it's like you already used that one. So that's like you cannot use the tower that you just used. So it skips the tower you just used to get the other
Mm,
towers. Okay.
yeah.
Okay.
So,
So
so basically, it goes to tower 0. It grabs the last element, right?
Yep.
So if that last element is so this tower, right? 2 tower. So this one is the second one because we said that 2 was the last tower, so it's 2, right? 2 plus 4 is 2 plus 2 is 4, right?
Yep.
Mod
Mod 3
3
is
is
1.
1.
Mm-hmm.
So it goes to
Tower
the
1.
tower 1. You see how we skip tower 2?
Yep.
Okay. So it grabs the element of that last tower and it compares. So if this so the element of tower 0 is less than tower 1, we always want the smallest ring, right? You wouldn't want the bigger ring.
Yep.
So we're using this one right here
Right.
because this one is smaller. Else, if this one is smallest, we use this one, right? So
Yep.
how we do that? So we make the new from equals parentheses 2 plus 1 mod 3, right?
Yep.
Because we want the basically we want the placement of the tower. We don't want the tower itself, okay?
Right. Right.
Okay. So that will be else else anyone knows what is here?
Wait. Can you go a little bit back onto that line? You said From 2 plus 1 mod 3, you said
Can you go a
we
little,
want the placement of that
little
of
bit
it, but not the
back
tower
onto that
itself.
line?
You said, are you saying you want
From
the
2
ring of
plus
it? 1 mod
or what?
3,
We
you
want the
said
ring. We
we
want the
want
ring.
the
Because you see
placement
how
of
it says
that
here
little
of
bit
it, but
T
not the
back
tower
onto
and
that
itself.
line?
bracket.
You said, are you saying you want the
That
ring
means
of it?
tower.
1 mod
Or what?
3,
We
you
want the ring,
said,
but
yeah.
we only want the placement
Uh,
because
uh,
we're not using because when we put this, that means we're gonna use back or something like that, right?
uh-huh.
So that when we use this, that means we want the rings. When we only look at the placement, it means the tower itself, not the rings.
So right now, would you use the one right there that you just highlighted? Is that
Mhm.
the
It's
tower
just
itself?
yes, tower itself. It doesn't have
Okay.
nothing to do with the rings. Okay.
Oh, so you're just declaring. Okay. Oh, okay. So that's like, wait, that's like the index number now.
Yeah, exactly. That's the index number.
Okay. Fine. Thank you.
Because from, remember how we initialize it, from equals 0. From is not a tower. From is
Right.
from is an integer,
Right.
right? So this number gives you an integer, right?
Okay. Wait. I
This
mean,
right here is a vector. If we make from equals a vector, that will cause an error because from was always an integer. We initialize it as an int, not a vector.
right.
You see?
So, but when you put in 0, you're saying it starts. We start off from
Tower
tower
0, the first
0.
tower.
Okay.
Yes, the tower that has all the numbers.
Got you. Okay. So, okay. I got you.
Okay. So if this has the smallest ring than this, we use this one.
Mm-hmm.
Else, anyone knows what goes here? Else?
Then we put from equals to the 2 plus 2. 2 plus 2 mod 3.
Okay. We're done with step 6. We're going to step 7, okay?
Yep.
Step 7. So we're gonna change our candidate. Our candidate is the ring that we grab and move. Okay?
Yeah.
So candidate is gonna be, what do you think is what the candidate is gonna be?
It's
Can
gonna
you
be
can you
from the one from the 2. Oh wait, no.
The one
Wait,
from the from tower, but
my
it's
bad. Yeah.
different with the end value.
right? So it will be the one from the from tower, but we want the back, right? Of the new from tower. Or it can be this one or this one, right? But now we want the ring, so we're gonna use the T back. And here it's gonna be from because we want it from the from tower now. So it's gonna be like something like T from dot what?
Back.
Exactly, dot back. So that's the candidate. You see, step 7 is easy. Step 8. So step 8. So this is where the hard part comes. Okay, this is a little bit tricky. Okay, because now we're gonna use the end closest and far. Now we use this part, right?
Yeah.
So what we want to do is a net if statement. If tower from, if the from tower, right, plus closest mod 3 wait, give me a second. I'm gonna do something wrong here. I forgot the parentheses. From plus closest mod 3 push dot back is, you know what, let's do it like this. Let's make it more simple. If candidate, right, if candidate is less than the from tower from plus closest mod 3. Okay.
Holy shit.
So 2 is equal.
Yo, my apologies. I quickly went out of my chair and I see we're on step 8. Can you tell me what, like, a quick summary of everything? Like a small summary?
Okay. Yeah, sure. Just let me finish this step and I'll explain, okay?
Okay, thank you, thank you.
Mod 3. Else mod 3 else 2 equals for from plus 4 mod 3. Okay. So where do you stop? You stop on step 7 or?
Yeah, like from step 7, from step 6 to step 8, like what is going on in each step?
Okay. So basically, we wanted a new from, right? Because we already
Oh,
we changed our from tower. Remember that we already did?
yeah. Uh-huh.
Okay. Okay. So now we want a new from tower. So basically, what we did is from tower 2, because we don't want to use tower 2. Okay.
So this
Because
is
we
the,
don't want
like,
to
where we're
do.
avoiding it, right?
Yeah, we're avoiding it.
Okay.
So we use +1 and +2 to avoid the tower. So let's see, this is tower. So this is the last tower, tower index 2, right? Because 0, 2, 0, 1, 2, right?
Uh-huh.
So this is 2 tower. So 2 plus 1 equals 3. Mod 3 is 0. So use the first tower. Here is 2. This one is tower 2 plus 2 equals 4. Mod 3 equals 1. So using the basically the second tower, index 1. And we're grabbing the ring for both. Then we're checking which ring is smallest, right?
Yeah.
If this ring is the smallest, we change this to from to this one, right? But we only use this without the tower, right? Because we want the index. We want an integer. This will give you a vector, right?
Yeah.
So we only use the basically the middle one, just like what gives you the index of that tower. Or else, if this one is the smallest, we use this one right here.
I see.
Okay. In order to find the new candidate, we basically grab it from the now from tower because we changed the from now.
Oh, so
So
now
we
we
do a
copy
tower.
the new tower that we got from the from.
Yeah, and the candidate is the ring that we move. So we basically grab the ring from the from tower. And that ring is what the ring that we're gonna move now, okay? So the candidate
So
is
that's
that.
the new candidate being moved.
Yeah.
Okay.
So step 8 is the hard step. That honestly I don't know how to explain it, but let's see. If the candidate
Um,
is
did you finish writing down step 8 completely?
oh yeah, that's
Oh,
everything for step 8.
okay.
So if the candidate, right? The ring, it has to be the smallest one. So the smallest ring that we can move. Okay? So basically what this does, it basically it checks the tower near you, right? It
Wait,
checks the tower.
can you just like give us like like a minute so we could like try to come up with something ourselves? Just like 1 minute, maybe.
Okay. And I'm sorry, I got confused a little bit right here. Wait, dot back. Here.
From what I'm looking at right now, it's just taking the new candidate and it's just moving it to another tower, right?
Uh No, we're basically choosing our two tower. What our two tower is.
Oh,
Yeah,
like
because the afterwards the instruction that comes after the if is a 2, like setting it equal to something.
Hmm.
oh, so from here does this loop back and go to the like
Wow.
step?
Yeah.
Okay, it goes through the while loop, and then the new candidate is now the thing that is being ran through this loop.
Hmm.
So this is essentially like making the candidate the new thing, like the new ring. It's choosing the new ring that is going to be looped back through this whole process.
Yes, but what this does is basically, here this thing is what chooses the new ring. This is basically it compares the other rings to see which one has the smallest. Like which one has the biggest, my bad. If this ring has the biggest and the candidate is smallest, we go to this one, right?
Yeah.
But if the candidate is bigger than one, we move to the other one that is the farther one, the other tower.
Okay, and then closest and
Um,
farthest are integers that are like that, and then we run the values of the integers in that.
Yes.
um, excuse me. So so basically, when you did the candidate, in line 50, so you're saying you're basically you're not sure if that one's actually the smallest one, right? So
Wait.
are you like? I mean, that's
No, no,
candidate. Uh huh.
no,
That's
no, no.
candidate.
I'm 100% sure this one is the smallest one candidate. What I'm
Then.
saying
Mm-hmm.
is with this, you're choosing the which one is the biggest, which one has the biggest ring, that because you're putting basically biggest, smallest, 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 right?
Uh huh.
If the tower with the closest, right? So let's say, oh, let me draw here. How do I erase this thing? File new. No. Okay. So basically, you're doing this, right?
Yeah.
3. And let's say you have a ring here, and you have one big ring here, right?
Yep.
And you have one little ring right here, right?
Mm-hmm.
Okay. So what is do the closest? It checks with this one, right? It checks with this one. If this one is bigger than this one, it works. So we can put it right here, right?
Yeah.
But let's say first was small. So this didn't exist. This was over here, right? It was a big one, right? So this one comes here and sees that this one is smallest than this one.
Yeah.
So it doesn't work. So it skips this one. It chooses the far one. So it goes to this one, right?
Mm-hmm.
So that's the code that I'm doing. It's basically here. So if it's not the closest one, it's the far one.
Okay. Okay, I get you. So it's just like checking.
Yes. So basically closest was to, yeah, it's like checking. Closest, where is it? Closest. It will be 2. So
Or
basically
one.
moving to the left, and the far, it will be 1.
Okay, so how many more steps are there to this?
We're done.
Oh, we're done? Okay, so here's what I'm gonna do, right? Could you share this? Yeah, if you could run it.
Let's run it. Enter number of rings. We're gonna put 1. Close your finger, guys. Did it work? I think it worked.
Um,
That's the answer?
I don't know.
I don't think it is working because you're transferring ring 1 from tower A to C and 2 and then like ring 1. Oh no, I think it's working.
It's working,
Right?
right?
How many steps? It's supposed to be I think there's like a fixed number of configurations for that. It's supposed to get let me see. 1 second. The number of rings.
Shouldn't they all be at Tower C at the end?
No, it's supposed to be a tower in the middle tower.
So B.
B.
Yeah, tower B. So I think like it's 2 to the power. No, n to the power of 2 plus 1, I think. Right? The
So
total
4 to the
configuration.
power of 2 plus 1.
So 4.
So it's 13 moves?
Wait, what?
So
Wait,
4 to the
16
power of
17
6.
moves?
No, she said 2 to the n plus 1.
2 to
Oh,
the
2 to the
power
power
of
of
n.
So 30. Wait, what? Can you say that
What?
again? Excuse me, I don't know
Wait,
what.
It's
what?
2 to the power no, n to the power of 2, I believe. Let me
So
N
check.
to the
4 power of 2
16.
plus 1, 17 moves, no?
Are you sure
Let
that's
me check. It's yeah, 2 to the power of n minus 1 moves. So if you put like 4, it should be 2 to the power of 4
correct?
times that.
Yeah, that's
16
it. That's
minus
it.
1, 15.
Yeah, that's it. That's it. That's it. This is
It's
it.
correct, it's correct.
Yeah. Okay, so here's
Okay.
what I want you to do right now. If possible, can you share me the code?
Well, let me show you quick.
Thanks. And then what I'm going to do is you're gonna tell me if if I have a perfect understanding of each of these parts. Like, alright, let me just copy this over to GDB real quick. Really good job, by the way. You explained it really well. But now I want you to tell me if I'm understanding it, and then in this case, if everyone else is also understanding it.
Okay, so let me check your screen, right?
Okay. So, step one, it's obviously like initialization is for the user input, right?
Wait, give me 1 second. I'm still not there. Like looking for you. Okay.
You
Okay,
can see
there
my
you go.
screen.
Yeah.
Someone, or it's whatever. So, step number one, it's just for user input, correct?
Yes.
Step number two, this is where each of the like integers are created for like each of the like it could be for the rings, it could be for the candidates, the closest, farthest, like those kind of like functions essentially, right?
No.
Step two, like this is what this exactly it's like the conditions that are being required to be met, right?
Yes. That's the
Okay.
conditions. Yeah.
Okay. Step three, this is where we like copy like the information in each of the tower and put it onto the next one.
Yeah. Initialize the towers. Like it grabs all the rings and put in the first element, and then put the how do you call that thing? I always forget the name. The sentinel to the other towers. That's what it does.
Okay, so it creates like the temporary like sentinel as well as like it puts the amount of rings in the first tower, correct?
Yes. Correct.
Okay. Step 4. Here this is just like an output like where it's like showing the exact amount of moves that were created, like a counter.
Yeah. That's yeah. Correct.
Step 5. This is where they copy, paste and then like create like the new ring in the next tower and erase the
Yeah.
one from
That's
before.
basically what moves the rings. That's the ring movement.
This is what moves the rings. Okay. Moves moves the rings. I'm just putting parentheses next to each of your steps. That's fine, right?
Yeah. No worry. Yeah.
Counter output. This is the Sentinel plus tower initialization. Yes? Conditions. Step 1. User input. So far so good, correct?
Mm-hmm.
Step 6. Here they do the they go to the next tower?
No.
No. Um two
Look at the
plus
middle
This,
one.
this
Look
one's
in the middle of
choosing.
that.
This one's choosing what's gonna be the from. Like which tower we're moving from. We're gonna take from.
Yeah.
Okay, so
We're choosing the new from tower.
chooses the new from tower.
Mm-hmm.
Step 7. This is choosing the new ring.
Yeah, choosing the new ring that is gonna be moved.
Be moved. And step 8. This is um seeing how close or far the ring is to a tower.
No. That's you choosing the tower that has like the bigger ring in order to move the candidate to. So you're moving the smallest ring to the biggest ring.
with the bigger ring to move the smallest ring to.
Yes.
Okay.
Um,
And then like it just loops back up.
Yes. It does it again.
Okay. Oh, that's cool. So if I do run it, and I put like, I don't know, 17. I probably shouldn't have done that. Jeez,
Damn, that's a lot.
that's insane. I mean, it's whatever.
Is
Like,
that an infinity loop? Is that an error?
no, because he said 2 to the 17 basically
Oh
minus
shit.
1.
That's crazy.
let me just check. Oh yeah, that's
Yeah.
jeez. I mean, it's going. I'm gonna stop it. It works. I think it works.
Can you
So
try it again?
again, okay,
Make it
We're
loop
like
3 or
we're like
something.
5. We're like 5.
5.
It should be 31, I think.
Yeah.
Yeah, it is. All right, so here's what I'm gonna do. I added these small little parentheses. Let me put a Tower of Hanoi
What have you
credits
guys gone
to
over through since
Chris.
yesterday?
You want to use your full name, Chris, or just Chris?
Christopher. Yeah, that's good.
Or Tower of Hanoi credits to Christopher. Okay, so I'm gonna send this out to General. OH Chris and gonna be Tower of Hanoi at Christopher. Anyone has any questions on this? Thank you so much, Christopher, by the way.
Yeah, Chris, did you were you here yesterday too? Or like what did you guys go over yesterday by any chance?
Yesterday, I don't think Chris was here, but essentially, Phoenix and Pikachu explained Rat Case. That's like the
Okay.
majority of the thing, Rat Case. And
Okay, so that mm-hmm.
Rat Case, I mean, the video is up still. It's gonna be up until like everyone finishes the final. Even if there's makeups, I'll keep it up for like a week later as well if needed. If anyone
Okay,
does
cool.
choose to. So it's session number 2. You're gonna see each of them are labeled Rat
Oh,
Case.
okay.
Um,
And then what was session 1?
Session 1 was actually Tower of Hanoi, but it was a different code. It checked even and odd compared to like whatever this. So there's like 2 separate codes for Tower of Hanoi actually.
Oh, really? Like what
So
are they kind of called?
Drew
Like topic wise?
Drew actually did it. He checked like the conditions of odds and evens. Here, let me.
Do you think we have to know both of them or just one of them would suffice?
I mean, if you understand one, I think it will be.
Yeah.
You
Whichever.
can get the other one.
Here, I'll
Yeah, because
actually.
this one seems pretty like straightforward kind of.
Yeah, this I'd say like you can choose either or. If you want, I could also just like here. I'll reply to this. OG session number 1. You can see in general.
Okay.
So this was done actually like 3 days ago.
Oh shit.
We did Tower of Hanoi like for the most majority of the session. Score the race briefly, pointers briefly, and obviously binary numbers briefly, very briefly. Anyone else has any questions for
Like
this?
related to this?
Yeah, related to this, like right now, or even anything in general.
Um, what is that overflow thing that I was hearing about, or overload, or I don't know what it's
Oh,
called?
Stack Overflow. It's kind of like Actually, matter of fact, since we're Phoenix, you there? Phoenix?
Yes, yes.
Do you want to do binary? And if anything, you could explain like the Stack Overflow and underflow with it.
Mm, Um, I don't know binary that much, so if anyone is like good on it,
I know
I would like
binary.
them to.
I know binary.
Okay.
You guys,
Oh,
mind if I
Chris.
do it?
Yeah, sure. Thank you, bro.
Okay. Let me do binary. Let me do-
Okay, so let's just take a look at the list. So right now, Tara Fano is taken care of. So I'm gonna the binary and Fibonacci. Are we all agreed on this, or do you guys want to do a quick recap on RAD class operators, really
Can we
quickly?
do a recap on rag class? But can we save that like for last, kind of?
Like just kind of fast.
Uh,
I think we need to take our time on that one because that
yeah,
one
yeah,
is really important.
Okay, so not a
yeah.
quick recap. Um, just in case, if you guys want the full explanation on RAD class, it is on session 2. Session number 2 is entirely RAD class. But other than that, if you just wanted a quick recap, we can go over that today. Like just an explanation of the code. Phoenix was the one who did the explanation behind RAD class, so she can explain all of it.
Okay.
So, do you guys want to
So
start on RAD class, or do you want to do binary and Fibonacci?
what do you think, Chris?
Also,
You want me? I can. Binary is really simple. If you want me to go over it.
You
So
know,
we
my suggestion is like we already explained red class yesterday. I think like if anyone needs more understanding on that, I think you guys should like watch the previous review. And if by then you still like confused a little bit, then we can recap later.
yeah,
Maybe like we're gonna study tomorrow also.
I
So,
agree. Yeah.
like in
Ju-
person we can do it better. Right now, like we should focus on like other things so that the people who cannot show up tomorrow or later can, like get get something.
Mm-hmm.
Yeah,
okay.
so I
Yeah.
forgot to mention that as well but at the start of the session. 2 p.m. tomorrow, John is actually hosting a in-person like meetup and like tutoring. So it's gonna be
In the
John with
library.
in the library. Yeah, John,
Can you
are you
guys?
there?
I'm sorry. I know that I said like I'll be at 2, but like there's been like a change of plans. So can you guys like maybe do at 12?
Oh, that would have to be entirely with John. I think John is gonna be there with someone named Steven. I don't know if I've met Steven before, but
Somebody
Yeah,
he's
said
yeah. I think like
some.
John and Steven said that they'll be there since like
the
the
morning.
morning, I
Yeah,
guess.
so you guys could be like you guys can congregate whenever. The general meetup time for everybody was 2 o'clock. So, cause I had some stuff to do before Orange. Oh, drives Orange. Wait, what? Cat. Wait, is John alive? John, you there?
John is not alive. He's just there, muted.
Oh,
He's pretending to be in the review, see?
bro, wow. He was asleep all this time. I mean, I don't blame him, bro. It's so much stuff to review for like one final. So
Just one more week.
one more week, bro. We got 2 days.
Oh yeah, just that.
Um,
Do we have class tomorrow?
I
um.
have for 240.
I don't.
So some people have tests tomorrow. That's another reason why, like, we chose 2 o'clock because some people have tests in the morning.
No, I mean for
Yeah.
Waxman.
Oh, for Waxman?
No.
No, no, no.
Waxman's Wednesday.
Oh, John's here. John.
I think every like 211 is on the same day, I think.
Yeah, it's on Wednesday. All the testing is gonna be in room 110 and 111. You can go into any room. It doesn't matter. So
Yo, did anyone call me by any chance?
yeah, I called.
Oh my god, you're alive.
What?
Bro, okay, I'm still on my laptop, but I'm in the shitter right now, so someone just texted me to join it real quick.
So yo, for tomorrow, what time like are you guys gonna be there? Like you and Steven? Oh, I did see Steven.
We'll probably be there like around 12ish or so. The poll should end in about an hour and a half. So whatever consensus that everyone gets from the poll, they can come around that time. If they want to come later, they can come later. It doesn't matter.
And
I'll be there
around
at 12, so I'll hit you up.
All right, no problem. I'm gonna go get some markers, so I don't have to borrow them for the library. So I'm probably gonna go buy some markers.
until what time are you guys gonna be there by some chance?
Bro,
I don't know. We can stay till whatever. If
like
you
as
guys want to
long,
leave, we can
yeah.
leave.
I'm bringing my meal prep with me, bro. I'm staying until evening.
Taz, you gonna stay with us all day?
Bro, most likely like 7, 8.
Nice,
Okay,
nice.
okay, bye.
Um,
Okay.
yeah. Other than that,
Chris?
it's just not gonna be recorded. I don't know how I'm gonna record something in person.
That's
I don't
fine.
think we can record in
Set up the tripod,
person
bro.
unless you have a like a like a GoPro or something.
Yeah, I'm not doing all
Anyone
that.
got like a spare camera they could use?
Um, other than that, I mean, so 12 o'clock tomorrow. Anyone, if you want, you could send out at everyone, John, and then like just let
What part
everyone
of the
know.
Yeah,
library?
no problem.
Bro,
You guys want
we'll
to do
find him.
second floor like last time?
Yeah, I think second floor is the best option because they got the couches and stuff, and it's like a big space.
Okay,
Is that
sounds good.
is that like like when you first come in the next floor up?
Down. When you
Down,
first
down.
come in, go down. If you go up, that's the quiet space.
Whoa, wait, down? So that's second
So
floor?
Yeah,
you enter the library technically on the third floor.
yeah,
Oh, really? Oh, I didn't know
yeah.
that. Okay.
The third floor is the main floor.
Oh, okay. All right. Thank you.
Yeah, no problem.
Um.
Other than that, anyone has any questions on the code?
No, but Chris wanted to say something
Alright, I
about the
love you guys.
overflow.
I'm gonna be back. Let me finish shitting. Goodbye.
Goodbye.
Yeah.
Wait, what were we gonna say, Chris?
No, do you guys should I do binary right now? Or
Yeah.
Yeah,
Yep.
I think that's if everyone's okay with that, and then rat class we do have a session on it, and if you want to do a
Yeah.
quick
Yeah.
quick recap, we could do that as well.
Okay.
I think
Yeah.
we should go today. I think we should go binary, Fibonacci, and then we need to do the question that you have, the freaking
Oh,
the
the final
overflow, the riddle.
riddle. Yeah.
I
So
think we need to do that today.
for those who don't know, someone sent me like one of the actual final questions from like one of the previous finals for 211.
Oh
Guys,
shit.
can I tell you something?
Yeah.
So I'm retaking this class, and yeah, that question was on my final.
Actually,
Oh, okay.
Yeah,
so we have confirmation as well. So there you go.
yeah.
So that's like
Nice.
an
Nice.
actual question from here. I'll put it up on my screen. I can't confirm who sent it in
You know
case
what we
any.
should do, guys?
Yeah.
When we take the final, each of us should remember like one number on the, we
One
should
question.
be like assigned, like let's say like you will take number 1, I will take number 2, and like someone else will take number 3. We should remember one question each so that we can make it into a PDF because Waxman never changes the questions, to be fair.
That's true. And then we can make it
True.
into a
True.
template, right, for future references. That's
Yeah.
true.
That's pretty
That's
cool.
pretty nice. So
Yeah,
my memory sucks. If anyone else is volunteering for that, like, that's a good
that's why,
cause.
like just remember one question. That's it. Whether it's like
Right.
question 1 or question 2, we should like assign each number.
Try
Right.
my best. So what
We'll
I
think about it later.
what I have on my screen is actually the question. If I don't know if you guys can see that.
Yeah. It says Rob the robot is having trouble getting to sleep, so naturally he resorts to counting digital sheep using a program written C++, whatever. Sheep in the first two panels behaved as expected. So what did they do as expected? Like, oh, they fell asleep. Each time he counts, the count increases by 1. But in the third panel, Rob is surprised all of a sudden that the count goes negative.
So basically, overflow it means that integer has a size, right? Because then you need to use long, or maybe you need to use um something bigger, right? Extra long, right? So because it has a size, while you counting, there's a size where when you get to the number, it comes back.
Yeah,
So it
actually,
goes into the negative.
yeah. So I didn't want to interrupt, but the number itself, it's actually I don't know if you guys can see it. It's 367, I think. Here, I'll try putting it up here. Uh, it's like the sheep goes from 1 dot 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 dot. It keeps on going, right? It goes all the way to 32,367, and then the next number is negative 32,367.
Okay.
So
And
that's
then it decreases.
yeah. It continues decreasing, and then what it goes whatever number it reaches. Like it doesn't show that, but in the cartoon it just shows that it goes from negative this all the way back. And so the first question it asks why does the count go negative, and like someone answered it, someone said 32-bit system causes an int overflow, runs out of memory, and crashes. So when you reach this number, it reaches integer overflow, and that sends it into a negative, and then it just counts down back to like 1, and then from there it just keeps on going up. It's kind of like a imagine. Do you guys know what number lines are?
Yeah.
So imagine a number line, right?
Yeah.
You are starting from like dead center. That's not dead center, but okay. Imagine you're starting right here. This right here is what's being represented as 0, I guess. Is it 0 or 1? Christopher.
What? Excuse me?
What do you say the center is 0 or 1?
What do you mean? I'm sorry, I got lost for a second in
No,
my
no.
A
thoughts.
number line, center of the number line. Is it 0 or 1?
Typically 0, no?
Yeah, it's typically 0, right? So you're counting like 1, and it like, at least in the picture, I don't know if you guys can see the picture. You know, you keep on counting. You see the sheep. It starts with 1, 2. It's going up in a count of 1.
Yeah.
So 0 and then 1. What happens is that you go all the way here. This is number 32,367. Right? What happens
Okay.
now? You're out of memory. You're out of memory. Where else can you go? There's nowhere to go. So what happens is you take this, you turn it all the way around, and you come back here. See? I don't know if
Yeah.
that's visualized it properly. But, so now what happens is this little thing. My bad. This comes here as negative 32,367. And the count continues. So
But the count goes to 366 or like 368.
Goes down.
it goes negative and it goes
back to 0.
yeah, it goes back to 0. So because if this keeps on decreasing, technically what's happening is the value is turning positive, right?
Oh, okay. So
Yes.
it's returning back.
It's
so-
returning back to 0, and then this loop continues onwards. You know, it goes from here all the way here, and then it comes back. You know.
Okay. Okay.
So-
So that's why they're saying, why did he get to that point?
Yeah. So from here it goes like all the way here. I should have made it into an arrow. I don't know if that visualizes it.
So the answer was it at 32. Wait, can you show that again?
Yeah, of course. Oh, my bad. At 32-bit system causes an int overflow. It runs out of memory and crashes. So, can you guys see the screen properly? It's very hard to see because the image is very low quality.
It's okay. I think I can make out most of the words.
Yeah, but so you understand the explanation on why this is happening, right?
Yeah, I understand it, but in his explanation, he kind of doesn't say he doesn't say
Yeah.
it restarts or something
So
like that.
most likely he would get like 2.5 points for this first part.
Right.
I'm unsure because I don't know who he or she or they, like, I don't know who they were that answered this question. And so, second question is, in class we worked, actually, before we continue with that, do you guys want to continue with binary or this?
Can we do? Wait, did you guys do did you have Li Zing Zhu, or I don't know if you? I forgot what's her name, but she's our lab instructor.
Lazing.
Yeah, Li Zing Zhu, I think Zhao.
I don't have anyone like, I have a Fei Lu Feng.
Oh, never mind, never mind.
Li Zhang Zhu, if you had any questions for lab instructors, in the lab section right below, you can see like everyone like asking questions. I think,
Anyway, this is recorded, right?
yeah.
Yeah, thank you guys. I will watch this tomorrow. I gotta go. Hopefully if anyone show up tomorrow, see you guys.
You guys will see me, yeah.
Yeah,
Yeah,
okay.
take care.
Bye.
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 Okay, so I kind of know a bit of the she wait, hold on. I think I made a small list of at least what she mentioned was is gonna be on the test, kind of. But she was just saying something about okay, overload plus minus. Well, this is basically it, right?
Overload plus and
No, no, no.
minus.
Overload is different.
That's different.
Overload is
Yeah.
for the rat class.
Yeah.
Oh, okay, okay.
Okay. So
Okay, so that one I could watch the video for. I could watch the video for
we
that
can do
one.
that, and if everyone is okay with that, we can do a quick like review for the rat class as well.
Oh,
But
okay. And
right now, do you guys want to continue with this?
um,
No, not really,
not
because
really. Yeah, I think
honestly, I can just put on ChatGPT and see
Okay, that too. Yeah. Um.
Yeah.
So
they said.
let's ask chat because there is others in here. But what's your guys' opinions? You're okay with this?
Yeah, I think so.
Okay, Harvey.
But what does everybody else think?
I don't know. Magic Archer said yeah. Zoo. Okay. No one else is saying anything. Oh, binary. Binary. So everyone wants to go into binary. Yeah.
Yep.
Yeah. Okay. All right. So this we will. Actually, let me do this real quick. This is for the sample. Copy. This I'll keep this just saved now,
Um,
and from here remove
what is type def about?
type def.
Yeah.
What do you mean type
Okay,
def?
you know how you make integers or doubles and stuff like that?
Yeah.
So basically type def, you grab a name that you put, like you can name it like dog, right? And make it an integer, right? So now integer is the same as saying dog. Or dog is the same as saying integer.
Okay.
If you put a type def, I think it's type def dog and then integer, or I think it's like integer and then dog. Something like that.
Okay, this doesn't seem that crazy. I think this
It's
one.
just changing the name or something.
Okay. Let me see what else. Oh.
Okay, so binary. Anyone that can explain binary right here?
Chris said that he knows binary.
So Chris, you want to take over again?
Okay, let me share my screen.
Okay, I'll just share. I'll share your screen for the stream.
Okay, so binary, do you guys want to know how to turn a number to binary or?
I'd say let's
How
do
deep?
everything.
How? Yeah. That's better. I think.
What?
Let's
He
do
said
like everything.
let's go
Let's
from
start with like
scratch.
the
He said.
very basic definition. What is binary?
Okay.
I know binaries
So
are zeros
binary
and ones,
is
right?
the computer language, okay? So basically, you know the code that we wrote, like for loops and while loops?
Uh-huh.
Yeah.
The computer doesn't see that, doesn't know what is a for loop. The computer sees everything as ones and zeros, okay? So the computer sees this. That's binary, okay?
Uh-huh.
Oh, what the hell?
Yeah.
Okay.
Yep.
So let's say first we're gonna start with numbers, right? So let's say you want the number 14, right?
Yeah.
So the best thing you can do is name everything like 1, 2, 4. Go by doubles, right? 1 times 2 is 2. Times 2 is 4. 4 times 2 is 8, right?
Yeah.
So always start from the right side, go left. So we want number 14, right? So 14, it will be 8 plus 4. How much is that? 12? Plus 2 is 14. So this one is a 0. So the binary number of 14 is 1110.
If I'm correct, binary goes up to 16, right?
Bro, binary goes into infinity. It can go 16, 32.
It's just squared.
Basically, is let me see. Let's say you want, let's say 5,454, right?
Yeah.
You want to do that number. So the best thing to do is 1, 2, 4, 8, 16. What else? 32, 64,
8.
128,
Like, yeah.
256. Oh my god, 256.
512,
You know
I
what?
think.
Let's do 300. Let's do 320. Okay?
Yeah.
Okay. So basically, oh, and the next one of this is 512, right?
Yeah.
So you always want to stop at a number that is that passes the 320. So 256 is still no longer, right? It's still no higher. So 512 is higher than 320, you stop. Right?
Yeah.
So now what numbers we need to make 320? So 256 we need. Okay?
Yeah.
256 plus 128, how much is that?
That's too high. No, wait. Yeah, it
Too
is too
high.
high.
So we skip this one. So that's a 0. Plus 64, 256 plus 64, how much is that?
That's 320.
320. 320, right?
Yeah.
So we 1. So we, and all of these are zeros.
Oh, so it's 101000000.
Exactly.
Oh.
So the, for 320 binary is 101 0 0 0 0 0 0. That's this number in binary.
So, what I'm gonna do is I'm gonna actually write down a Google Drawing statement. But I just like to keep notes on Google Drawing so I can share them. So this is for binary credits, Chris. So okay, I'm gonna do your explanation real quick.
Yep.
So binary is essentially the main language that computers speak. And it is only zeros and ones.
Mm-hmm.
It is only zeros and ones. It is identified as what number value fits within. Actually, no. Binary has identifiers, right?
Mm-hmm.
Starting at 1 and doubling for each one, each time. For example, it goes from 1 to 4, 8.
I don't recommend doing that because remember, start from the right, go left. So you should do dot 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 4, no, dot 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 8 4 2 1. Yeah.
Okay.
No, it starts at 1. Yeah.
Okay. So it starts from the highest number. Starting at.
I mean, if yeah, because you don't use 0, right?
Yeah.
Everybody knows that 0 is 0 in binary as well.
And an example of a new number turned binary be 16 is equals to 10000, right?
What? Let me one. It's 1 2 4 8. Yeah, correct.
Or since 16 8 4 2 1 1 0 0 0 0. Actually, I have a good analogy for this. You can think of these as on and off switches.
Yeah, basically. Mm-hmm.
Which values are being turned on, pause, by within this route. So as you can see, 16 is matching with this. I'm actually going to the think on and off switches. See which values can be turned on, no diddy, to add
So if the
up
number,
to the number.
so the number, if the number is 15, right? You will need to turn on 8 and 4, so that's 12. So then you turn on the 2 as well, so that's 14, and then you turn on the 1 as well. But the 16 will be off. So we everything except the 16.
Okay.
See how it's 8 plus 4 plus 2 plus 1, Harvey. And so that's 15.
8, 4, 2, 1. Let's show the work for this. So it's gonna be 0 here. We can do 1, right?
Yeah.
1. Then this is
1, 1,
12.
1.
1. 15 is equals to 1, 1, 1. And then let me do lights red here. And oh, I don't know if that. Red and green.
Yeah, but
0, 1, 1.
we almost you know almost like never use the 16, but like you always use the numbers that are shorter than 15, no above. So the answer would be like 1, 1, 1, 1, 1 for once. You don't have to put a 0.
Oh, okay. So no need for the 0.
Yeah, no need for 0. Yeah.
Okay. So everyone has an understanding of this, right?
Yeah.
Yeah. If the number is 15, thanks. Yo, Cass, can you send me the riddle in the DMs? Yes, I got you. Oh,
Okay, so how to turn? You guys know how to turn into negatives?
for binary?
Like, um, I just remember that there's like a 1 in the front or something like that.
Okay, let me explain. Where's this thing? Oh no. Okay, so we won the number. What number we won? We won the number 8, right? 8. And we won number -8. Okay?
Oh,
So for number -8, so I always recommend to do this the first thing. 1, 2, 4, 8, right? Always. So it'll be like 1, 0, 0, 0. Okay? Here we are gonna, for negative, it's like we're gonna switch it around. We're gonna flip them. So it'll be like, it will be 0, 1, 1, 1. Okay?
uh-huh.
And does this only happen because the 1 is all the way at the front?
No, wait. Like, wait. We're not done yet. That's not it. Then we're gonna add a 1 plus 1.
Make it into positive.
Then we go 0 plus 1. I mean, wait. 1 plus 1 is 0. We take the 1. 1 plus 1 is 0. We take the 1. So 1 plus 1 is 0. We take the 1. And 1 plus 0 is 1. So because it's 1 plus 1, and it's like max number you can have is 1, that's why it turns to 0 and we take the 1. You cannot have 2 here. So give me a second. Why did I get the same answer? -8 in binary. Um,
If you search a binary calculator, you could also use the.
binary. Oh, here. What the hell was him to Amazon? Calculate here, binary calculator.
Wait, just convert
Uh,
your decimal value to binary value. Just do next.
-8. Yeah,
Huh?
bro, he literally put a negative in front of it. Wait. Binary subtract.
Yo, I'm gonna lie, negatives kind of got me cooked.
Binary. How to convert. Wait, what is -8 in binary? In binary, no. Okay, so 8 in binary is 1000.
Huh?
Oh,
Oh, okay, wait. I think I get it though, cause they're going into overflow just so they could get that answer, right?
wait, 8 binary in 8 bits. I want it 1 in 4 bits. Yeah, it's the same thing. It's the same thing. You see? Because you see how it did 1000, then we flip it when we add 1, so it's 1000 again. So
So regardless if it's
-8 in
negative or
binary is
positive,
1000.
regardless if it's negative or positive value, it's gonna be like whatever it's we
It's
get
not
in.
always like that. It's not always like that. So make sure. I don't know why 8 did this, but it's not always like that. Make sure you did this. First, you flip it. How we did it here. Where is it? First, we flip it, and then we add 1. Okay, so then we need to. And yeah, so then we add 1, because it's only the maximum is 1, we just need to change to the second one. So this one is 0, and then because this one we drag the 1 to, uh, this cannot be 2, so it will be 0. So, and then because we have a 0 in the last one, right? We can add 1 to it. That's why this one is 1. So it's almost the same thing. Now let's do a new example. Let's do 22. But I'm gonna guys let you guys do the thing for me. I'm just gonna write for you.
Okay, so first we list out like each of the values.
Okay, so 1,
So
2,
two,
to what number? Wait. 1, 2, 1, 2. 1,
1,
2.
2, 4, 8,
Okay.
16, and then 32. But then we don't use 32, but that's just like
Okay, so we leave it at 16.
yeah. So let's do one value for 16.
Okay.
We can't do 8. That's too high. So let's start at 0.
So what we use?
So 1, 0, 1,
1, 0.
1.
Look, we have 16. Let's add 4 to make it 20.
Yeah. So 1 on that, and then 1 on 2.
Okay.
Rest are 0.
Okay. So this is 0 and 8 is 0. Okay, so that's 22 in binary. Well, now we want -22. What do we do?
We add 1 to the 0. Correct?
No.
Let it all the way to the right.
No. First we flip.
Oh, we flip it around, so it's gonna be 0, 1, 1, 0, 1.
Yeah, 0, 1, 0, 0, 1.
Oh,
Now what do we
we
do?
flip each of them.
Yes.
Okay.
Now what do we do?
Now we add 1.
Okay, +1. Add it.
So 1 plus 1, it's gonna become 0 in binary terms. Now we
Okay.
bring a 1 over. That's gonna become 1.
Okay.
And this stays 0, right?
Okay.
1. And since it's not gonna be 0, it's just gonna be 1.
No, it's 0.
Oh, we bring
We
that
just
down
bring it
too?
down. Yeah.
Okay.
It depends on the number of bits that they ask you. If they ask you for like 5 bits, you put the 0. If they ask you like for 4 bits, you only use the 4 numbers that we use.
Okay,
You don't use
I
the 0.
see, I see, okay.
So this is -20, -20, -22. You see
And
how
if
it's
we
different?
yeah, if it's 22, it's 10110. If it's -22, it's 0101.
Yes, correct.
Nice.
So first flip and then add 1.
Sorry about
So, so it's always We flip
Yep.
it. We flip the ones with the zeros, and then we just add one. When it's 1 and 1, it does zero, but we carry the one again, and then we do the same process until the end.
Yes.
Okay.
Okay. Yeah, so that's binary. So you guys now know how to turn to a binary, and also you know how to turn to a negative binary.
Yeah.
Yeah, that's
So
good. That's it.
so basically, when we want to do the negative, first we start off by the positive one, and then afterwards, since if they
Yes.
ask for the negative ones, then we just proceed to flip them and then add one.
Yes.
Okay. Yeah, I get this now.
Okay. So that's binary.
I'm gonna
Um.
now let me just add this on to the yeah.
Okay. Oh, Taz, can you send me the rat class, the
Oh yeah,
code
of
for it?
course, yeah.
Yeah.
Um,
So I'm gonna have to dip right now. Yeah. And thank you guys for everything.
of course.
Thank
Um,
you. Thank you.
no, yeah, thank you, because you helped us out with Tower of Annoy again. And
Yeah.
as for rat class, let me search up rat.
Chris, you're gonna get on tomorrow, like later.
Oh yeah, I'm gonna be tomorrow. Yeah. But I'm gonna go over rat class in the morning, and when we go back on, I'm gonna be ready for that.
Wait, when? Wait. What are you gonna? How are you gonna? How are you gonna? I'm sorry. What
Hmm?
did you say for tomorrow in the
Oh, I'm
morning?
gonna
What?
I'm gonna I'm gonna study rat class like on my own, and
Mm,
then when I understand everything, I'm gonna because the thing is that I like to like show and teach because it helped me remember and study as well.
right, right.
Yeah, yeah.
I don't know if you
So,
could see it.
what time are you gonna go over it tomorrow? What time do you think you can? Like at night
Um,
again?
yeah, probably at night.
Okay. Like like at
Yeah,
9 or what?
it's the same time, honestly.
Okay,
Or like
that's
probably, yeah, you just text me and be like, "Hey, Chris, tomorrow. I'm
it's
gonna be all day studying." Yeah.
yeah. It's because I have a final at 8, 8 to 9. So
Oh shoot, good luck, man.
thank you, man. So yeah, maybe like at 9 if you can.
Nice.
So Chris, I sent it. Like it's called source code, right? But
Uh huh.
it's not in a C file. Let me just put it in a C file for you. Okay, give me a second.
Thank you, man. Wait, Mateo, I feel that I know you, but I don't know from where.
AV.
Were you? Oh, you were in Navy? Yeah, yeah,
Yeah, Vidalcito.
yeah. Yeah. Oh
Yo, you went
shit!
to aviation?
Wait, how come you changed to
Uh,
Marines or what happened?
yeah, I mean, yeah, I guess so.
Yo, do you
Nice.
know an IR?
I'm sorry,
You know an IR?
an IR.
Yeah, he did 50 at
No,
AV.
like recently.
Like I don't know, like a couple years back, I think. Cause I'm in
When
my.
did he? When did he? What year did he graduate?
Oh, yo, I can't even tell you correctly, bro. It's been a minute since I talked to him. But
An IR. Nah,
yeah.
bro.
What about a Juan? I don't know how many
Bro, there's
Juans are.
so
Yeah, there's so many,
yo,
right?
I'm gonna be honest with you, bro. There's a lot of like I don't know if you call them Desi people or whatever, but like there's a lot of them there. So I can't. There's so many
Yeah,
people there,
it's too many, right? Yo, what about a Zarif? I don't know. It's a dude with glasses.
bro. Nah.
Wait, you know?
No, I said no. Like I don't know Zarif. I have no idea who you're talking
Oh
about. I'm
shit.
sorry.
Yeah.
Nah, you cool, you
Do you
cool.
know anybody like sports related? Maybe I would know by then.
Um, yeah, nah, probably not. I only know like those three folks from
Ah, nah, bro. I'm sorry, bro. Like it's pretty big, kind of, in
PM.
my opinion.
I
Nah, it's
guess I
cool.
have to go.
Alright,
All
good.
right,
Looks.
all
Of
right.
course.
Take care, Brody.
I send the code
You
in
too.
the chat, like in general, by the way, for Rad Class Session 1.
Okay, thank you, bro.
Or, so, wait, no,
Okay.
is that Rad Class or is that?
Let me see what is that thing.
Pero si te fuiste a misa hoy día
It
o
is.
qué?
No, no,
Para
bro.
el examen, bro. Para el examen.
That is Rad
Oh
Class,
no!
yeah.
Oh my god, bro, that's a lot.
It is a lot. It's insane. I think it's like 100 lines.
Damn.
Yeah, it's 130 lines.
What?
Fuck, bro. What the fuck? Oh my god. Okay.
All right. Take care, guys. Thank you so much for your
Or
time.
that's all for today, right?
Mateo, hit me up, man. I didn't even know you came to Queens. What the hell?
Yeah, I mean, if you want, we could play handball when spring comes or some shit.
I bet.
All right. All right. Take care,
Bye,
bros.
bye, man.
O mándame el Insta.
Okay, bro.
All right. Peace, bro.
Alright.
Later.
Bye, guys.
Bye. For the remaining of us, do you guys have anything you want to go over? I'm not the best at explaining anything, but if you do want to go over some stuff, you could always do that. Up to you guys. With the remaining 3 folks. Hello. I'm just looking at chat right now, so if you guys have any requests or anything. If not, I mean, okay, so I see someone is typing. Blank. I gotta go to finals, right? Yeah, I think let's take an early night tomorrow, unless like there's like very specific questions. I'm gonna finish up this negative part, and then yeah, I guess nothing else, right? Yeah, of course. Yeah, least I can do. The stream, it's always gonna be up, so I'll always share the stream like in the general chat. Other than that, I'm just gonna end the stream now. So you guys had a good session. End it right now, okay? Take care, guys. Yep. Good night.